Yeah, good evening, everyone. Good evening. Good evening. Yeah, actually, class is 7:30 because of some technical issues. I made the class as 8:30. Yeah, fine, perfect. Let's call everyone. Let's call everyone. Post in every group. Please post in every group. Post in every group. Let's start. Let's start the session. Let's start the session. So today's class, first problem. It is going to be very tough problem. This problem is going to be very tough problem. Right? Careful, everyone. This problem is going to be very tough problem. Right? So how it is going to be solved? Right? This problem will give a lot of happiness. Trust me, this problem will give a lot of happiness. This problem followed by next problem. Both are similar. First what we will do is we'll do this problem first. Then we will go to next problem. First we will do this problem. Next we will go to the next problem. Can you see this problem one time? Can you see this problem one time? First let me know audio video okay or not. Is audio video okay? Ayan, good evening. Good evening, Ayan. Ayan, call everyone. Ayan, call everyone. Yeah, good evening, Sakshi. Good evening, Ayan. Call everyone. Call everyone. Yeah, today's class, it is the first problem. Today's class, it is the first problem. Can you go ahead one time? Read it. It is a very tricky problem. Read it. Assume that a method sort algorithm in the worst case takes 30 seconds for an input of size 64. Which of the following most closely approximates the maximum input size of a problem that can be solved in 6 minutes? Which of the following most closely approximates the maximum input size of a problem that can be solved in 6 minutes? It's a very, very interesting problem. It's a very, very interesting problem. First read this problem. Whatever you are thinking, you try first. Whatever you are thinking, right? First you do this. Merge sort algorithm in the worst case takes 30 seconds for an input of size 64. Which of the following most closely approximates the maximum input size of a problem that can be solved in 6 minutes? It's one of the toughest problem. This problem and next problem. These two are going to be little bit tough problems. These two are going to be little bit tough problems. Right? Let me start now. So before going to solve this problem, I want to ask all the people one thing. What is the merge sort time complexity? So this question is based on only that sentence. What is the merge sort time complexity? Can anyone give the answer to me? What is the best case time complexity? What is the worst case time complexity? If you want to know answer for this problem, please first of all clarify what is the merge sort best case time, what is the merge sort worst case time. Please confirm this first. Everyone, before going to give answer for this, please let me know what is the merge sort best case, worst case, average case. He is asking worst case, okay. What is the best case? What is the worst case? What is the average case? Everyone reply. Don't sit idle. It is not the time to sit idle. Right? The age group 20 to 25, 20 to 30, you cannot sit idle. If your age group is 20 to 30, you cannot sit idle. It is not the time to sit idle. Please respond, everyone. What is the time complexity of merge sort, best case, worst case, average case? Make it fast. Merge sort algorithm, what is the best case time, what is the worst case time, what is the average case time? Everyone have to give. Everyone have to give. And one more thing I want to ask you. In the merge sort time complexity, who is the major person? Comparisons or spare? Who is the major person? Comparisons or spare? Someone is saying time complexity n log n. I agree. Next one. In the merge sort time complexity, comparisons or spare? Which one is bigger? Make it fast, bro. Make it fast, yeah. Make it fast. In merge sort time complexity, who is the major one? Comparisons or spares? Time complexity n log n. I'm happy. Time complexity n log n. I'm happy. But in the merge sort time complexity, which is the major one? Comparisons or moves? Comparisons or moves? Everyone have to respond. Merge sort time complexity, who is the major one? Comparisons or moves? Moves. IN moves. Please read the merge algorithm one time. Please read the merge algorithm one time. M plus, right? M plus n minus 1 comparisons in the worst case. But moves are m plus n. Moves are m plus n. Moves are more. So if someone is talking about merge sort time complexity, indirectly they are talking about merge sort move operations. Moves are more. Time complexity based on comparison and moves both are right. That is fine. But a majority is moves. Right? Best thing is those people who don't know. Best please our class over. Please revise the class notes one time. Please revise the class notes one time. You will get the clarity. Now I am starting. See this problem carefully. See this problem. So listen everyone. I am writing. See this one. To sort, careful. This is the only statement which I know. To sort n elements. To sort n elements using merge sort. To sort n elements using merge sort, right? Time complexity is. What is the answer? N log n. Remember, n log n moves or n log n operations. In the place of moves, I written operation. That may be comparison, that may be spare. That may be comparison, that may be moves. Instead of writing moves, I simply written n log n time, which is nothing. If you want, you can write. To sort n elements using merge sort, n log n time complexity. See this one, n log n time complexity, which is nothing but n log n operations. N log n operations. Careful. Please be careful with this line. To sort n elements using merge sort, n log n time complexity means n log n operations. N log n operations. Now listen. Now listen everyone. Operations. Right? This is the only statement which we. This is the only statement about merge sort I know. To sort n elements using merge sort, n log n time complexity means n log n operations. This is the only one which we know. Now you can see the problem, you will get the clarity. Assume that merge sort algorithm in the worst case takes 30 seconds for input of size 64. Right? This is the statement given. 30 seconds it is taking for input of size 64. Right? Now listen everyone now. 64, see this one, from the given information, I can write like this. See this one, from the given information, like this. See this one, 64 elements to sort. 64 element to sort. Time complexity taking how much? Given information, 64 element to sort using merge sort. Using merge sort. Right? How much time it is taking? 30 seconds time it is taking. Right? 64 element to sort using merge sort, it is taking 30 seconds, which is nothing but, listen, which is nothing but 64 elements, right? 64 elements sort using merge sort, it is taking 30 seconds. What is the meaning of this one? 64 into log 64 base 2 operations. That may be moves. 64. When you say merge sort time complexity n log n, So 64 into log 64 base 2 operations. Operations will take time. Will take time. 30 seconds. That is the meaning of that line. 64 element to start using merge sort 30 seconds, which is nothing but 64 into log 64 base 2 operations will take 30 seconds time. Let's simplify this. Let's simplify. 64 log 64 base 2 can be written as, I think 64 is 2 power 6. 6 into 20, right? 6 into 64. 6 into 64. Operations will take time 30 seconds. So which is nothing but, right? Which is nothing but, can you help me now? One operation will take how much time? Or one move will take how much time? One operation will take time is equal to 30 seconds by 6 into 64. Right? Remember, I am not done anything. Right? This is the right. Remember, next time onwards, please take care. See, I know only this statement about merge sort. I know only this statement. What is that one? To sort an element using merge sort. To sort an element using merge sort, n log n time complexity means, right, n log n operations. This is the only thing which I know. Right? From that, let's see the story. 64 element to sort using merge sort, 30 seconds time, which is nothing but 64 into log 64 base 2 operations will take time 30 seconds. Means 6 into 64 operations will take time 30 seconds. One operation will take time how much time? 30 seconds by 6 into 64. This is the story which I know from the given information. Now observe the story. Now observe one more thing. Can you see this? Which of the following most closely approximate the maximum input of a size problem that can be solved in 6 minutes? It is simply saying how many elements you can sort in 6 minutes time. Right? If the above information is given, now is asking which of the following most closely approximates the maximum input size of a problem that can be solved in 6 minutes. It means in 6 minutes how many elements you can solve. Let us assume X element. X element can sort using merge sort. How much time? 6 minutes. Which is nothing but 6 into 60 seconds. X element can sort using merge sort in 6 minutes time. Normally you only say X element can sort using merge sort 6 minutes time. So 6 into 60, okay. X element actually to sort how much time? X into log X base 2 operations will take time right? 60, right? I think 6 into 60, I think 360 seconds. X into log 360 seconds. Be careful. Listen. Now X into, you only say X into log X base 2, X into log X base 2 operations. One operation time already you calculated. 30 seconds by 6 into 64, which is equal to 360 seconds. So for which X value left is equal to right. Substitute for which X value left is equal to right. Substitute one by one. Suppose assume that X I will substitute 512. Assume. Then it will become, if at all X is 512, can you see this one? If X is 512, can you see this one? This will become 512 into log 512 base 2, which is 9, into 30 seconds by 6 into 64. So this can be written as 2 power 9 This can be written as 2 power 6. Both will be cancelled. It is the 2 cube. Right? And one more thing. 6 cancel. 6 5s. So I think now see this one. 8 into 5, which will goes to 8 into 5, 40. 40 into 9. I think 360. So left came 360, right also 360. Both are 360. So if you substitute x by 512, if you replace x by 512, then left is equal to right. Answer is 512. Answer is 512. I have not done anything. From the given information, one operation time, how much I calculated? This much time. Now, right? Right, see this one. In 6 minutes, how many elements you can sort? Assume x element I can sort. Actually, x elements required x log x based to operations. Right? X element required x log x base operations will take this much time. So one operation time you substitute. Then left and right both should be equal. So x is equal to 512. Means 512 element you can sort in 6 minutes. 512 element you can sort in 6 minutes. A very, very interesting problem. Similar kind of problem can be asked for any sorting technique. This model can be asked for any sorting technique. Any sorting technique, this problem can be asked. For any sorting technique, this problem can be asked. Please let me know if you have any small doubt also. This problem can be asked for any sorting technique. Any sorting technique, this problem can be asked. You will simply replace merge sort by quick sort. You will simply replace merge sort by selection sort. You will simply replace merge sort by heap sort. You will simply replace merge sort by, right? Merge sort by bubble sort. Merge sort by insertion sort. Remember, this can be used. This can be asked 50 ways. This problem can be asked. It is one of the famous problem. This is one of the famous problem. If something not clear, let me know. See, I know only this statement. I know only this statement. Other than this statement, I don't know. Other than this statement, right? Other than this statement, see, so other than this statement about merge sort, I don't know anything. Only this statement I know. What is that one? X element, right? See this one. N element to sort n element using n log n time complexity means n log n operations. That is the only statement which I know. Now from the given information I have to use fouls. This one, 64 element to sort using merge sort 30 seconds. That means 64 into log 64 base 2 operations will take 30 seconds. Means one operation time is 30 seconds by 6 into 64. Now is asking in 6 minutes how many element you can sort. Assume x element I can sort using merge sort in 6 minutes. Actually, x element to sort x into log x base 2 operations right time required. X into log x base 2 operations time required. Right, but which is equal to 360. Then what is the one operation time? After substitution, now check options one by one. For which x value, both left and right, both will be equal. X is equal to 512, both will be equal, left and right. This is one of the famous problem. I don't know how many people got it. I really don't have any idea how many people got it. I really don't have any idea how many people got it. Someone is saying that sir, sometimes there are lags. Voice crack sometimes. Sir, lagging. Can you check once? Hi. Yeah, it will be there. Iron, it will be there. Maybe, right? It's a net issue. Right? Net issue. Hi, everyone. Let me know. Is it okay now? Is it okay now? Check one time. Sometimes it will happen. Sometimes it will happen. It is a peak time. It is a peak time normally. It is a peak time. 8:30 means peak time. 8:30 means peak time. Many people, many buffaloes are using internet now. That is the indication. Many buffaloes are using internet now. Many buffaloes are using internet now. So normally, this is the busy time. Normally, most of the time I identified. This time there is some issue. This time normally there is a issue. due to weather. Weather is the one thing, and many people will use this point of time. Morning mostly no problem. Sir, can you show once with the quick sort? Quick sort worst case how much? You only say quick sort worst case how much? Quick sort worst case how much? Bro, quick sort worst case how much? Yeah, n square. In the place of n log n, simply write n square. In the place of n log n, see, n log n is 64. N log n, simply write n square. Just calculations will differ. Right? In the n log n place, write n square. Can you help in a quick sort best case? N log n or not? Quick sort best case n log n. Quick sort average case n log n. Quick sort worst case n square. Just numbers will change. Just numbers will change. Same thing, heap sort also. Heap sort every case same. Heap sort, merge sort similar. Heap sort, merge sort similar. That is also n log n. Same question replaced by merge sort by heap sort, same answer. Merge sort replaced by heap sort, same answer. Merge sort replaced by quick sort, then not n log n, because of he's asking worst case n square. This problem, he can ask you 50 variations. This problem will be asked in the 50 variations, not one variation, two variation. 50 variations they can ask. This problem can be asked in the 50 variations. Please try to understand. It will be asked in the 50 variations. Yeah, can we move to next? It will be asked in the 50 variations. Anything, so similar kind of thing, right? Iron, they can ask anything. They can ask anything. See, I can say one model. You can mold to any problem. I can say one model. You can mold to any problem. Need not be searching, need not be sorting. Anything they can ask. Model is this one. This is the model. Anything they will ask. This model will be asked for anything. Can you go to one more beautiful problem? Can you try this? It's very interesting. Can you try this? Can you try this? The number of elements that can be sorted in theta of log n time using heap sort is. The number of elements that can be sorted in theta of log n time using heap sort is. Try once. The number of elements that can be sorted in theta of log n, sorted using heap sort. It's a one more nice problem. It's a one more nice problem. I don't know how many people will give answer. I don't know how many people will give answer for this. Please, can you go ahead? Similar problems. Similar problem. That is the reason I kept side by side. Similar problem. Similar problem. That is the reason I kept side by side. That is the reason I kept side by side. Similar problem. Let's see how many people will give. This is option A. Option B. Option C. Option D. Yeah, go ahead. Go ahead. What is the answer for this? Everyone try. What is the answer for this? Go ahead. Let's try what the answer. Very less people can give. The number of element that sorted in theta of log n time using heap sort. Right. Now my question to everyone. It is similar to previous problem. It is similar to previous problem. Exactly similar to previous problem. Right. Now see this. See this one. See everyone. Normally what the heap sort will say is, an element to sort using heap sort. This is the only statement which I know. An element to sort using heap sort. Right? An element to sort using heap sort. N log n time complexity, which is nothing but n log n operations. That may be whatever it may be, operation, maybe comparisons, maybe swaps. This is the only statement which I know. An element to sort using heap sort, n log n time complexity, which is nothing but n log n operation, right? For every time complexity means it is take for every operation it is taking some time. N log n time complexity means n log n operation, because every operation will take some time. So there is some n log n work is there. So time complexity became n log n. That operation may be comparison or swap, whatever it may be. Everyone know heap sort time complexity n log n. Everyone know. So to sort n people using heap sort, n log n complexity. N log n everyone knows. This is the one which everyone knows. Now observe. Now observe everyone. This is the one which everyone knows. Now observe. Right? Be careful. Same story like previous. Same story like previous. Can you help me now? In this problem, is there any way is he given? See this one. In the merge sort problem, is he given anything to find out one operation time? To find out one operation time, are they given any input? In the merge sort problem, to find out one operation time, are they given anything? In the merge sort problem, to find out one operation time, are they given anyway? They given. See, first paragraph is given. Assume that a merge sort algorithm in the worst case take 30 seconds for input of size 64. They given. From there I find out one unit operation. Lastly is asking in 6 minutes how many elements you can sort. In 6 minutes how many elements you can sort. So they given something, based on that they are asking something. But if you observe clearly, listen, if you observe clearly, the number of elements that can be sorted in theta of log n time using heap sort is directly asking how many elements you can sort in log n time using heap sort. Right? How many elements you can sort using theta of log n time using heap sort. So I think he's not given any other information. So one operation time, there is no way to calculate. See, in the previous problem, one operation I used it. Now he is not given, so I don't have any other option. Right? Now see this. An element to sort using heap sort, time complexity n log n. Now see the answer. See the answer. He's asking theta of log n time. In theta of log n time, how many elements you can sort? Let us assume x element you can sort. Let us assume x elements. He's asking theta of log n time using heap sort, how many elements you can sort? Assume x element you can sort. In theta of log n time, right? How many elements you can sort using heap sort? Assume x element you can sort using heap sort. Assume this. But one thing, assume x element you can sort using heap sort, then using, right, this much time, theta of log n time. But actually, x element to sort, it is taking theta of log n time, okay. But actually, how much required? Because of it is the heap sort, x log x base 2. X log x base 2 time it will take. X log x base 2 time. X log x base 2 time it will take. Actually, this much time, which is equal to theta of log n. So X element to sort using heap sort actually this much time, which is equal to theta of which X value both left and right equal. Which X value both left and right equal, we have to calculate. Right? So listen everyone, he is simply asking one thing, theta of log n time, in theta of log n time using heap sort, how many element you can sort? Let us assume X element I can sort. X element to sort actually X log X base 2 time required, which is theta of log n time. So which X value both left and right both are equal, check. Let me check here. If I replace X by C option, can you see this one? If I replace X by C option, see what will happen. If I replace X by C option, what is the C option? Log n by log of log n, means log of log n. Log n by log of log n. Assume X is log n by log n into log of, again see, what is the X? Log n by log n. Right? N into log n into log. This much time, actually this much time. If I substitute the third option, log n by log n into log of log n by log n. Now simply substitute log n by log n into everyone now log a by b formula, log a minus log b. It will become log of log n minus log of log n this time. Now one more thing, try to understand. Asymptotically, if you observe, this is the bigger one, this is the smaller one. Bigger one minus smaller one. Bigger one will dominate. Small thing you can neglect. Then it will become log n by log n into log n. Log n cancel. Finally, it is log n. Remember, left log n, right also log n. See, for which X value both are equal. I think X value, if you replace by C option, if you replace X by C option, if you observe clearly, left also came log n, right also came log n. I think C is the answer. Right? He is saying theta of log n time using heap sort, how many element you can sort? Assume X element. Actually, X element to sort, X into log X base 2 time required, which is equal to theta of log n. Which X value both are equal, check. But remember, it is a theta, asymptotically equal. It's not mathematically equal. It is a theta, asymptotically. Small constant you can neglect. Small constant you can neglect. Replace X by log n by log n. So X by log n by log n, log of X by log n by log n, log A by B formula, log A minus log B. So bigger one minus smaller one, bigger one will dominate, take the bigger one. So log n by log n both are cancelled. Finally, log n is left out. Answer is C. Right? If at all you are doing first time, you have to substitute one by one. Check option A also, check option B also, check option C also, check option D also. Right? If you check, you got to know that all will be failed. Only C will be passed. It's one of the nice problem. Let me know anyone having any objection. Let me know if anyone having any objection. Let me know if anyone having any problem. Yeah, sometimes it will happen. There may be a net issue. It is a part and parcel of the online classes. Sometimes it will happen. That is also the peak time. 8 o'clock is a peak time. 8 o'clock is a peak time. Yeah, it's fine now. Yeah, it's all, see, almost both are look like aptitude, but you should know fundamental concept. You should know fundamental concept. You should know fundamental concept. Other than this, nothing there. Fundamental concept you should know, right? Fine, fine, fine. These two are very nice problem. Can you see this? Can you see this problem? Consider the directed graph shown. Consider the directed graph shown in the figure below. Some figure is given. Consider the directed graph shown in the figure below. Okay, one figure is given. Okay, that's okay. Assume that in any iteration, the shortest path to a vertex V is updated only when a strictly shortest path to V is discovered. Starting from vertex S, what will be the sequence of vertices identified by Dijkstra's algorithm? You want to say that if you apply Dijkstra's algorithm starting from S, right, what will be the sequence of vertices you selected? Remember, in any iteration, the shortest path to a vertex V is updated only when a strictly shortest path to V is discovered. Simply is asking, apply Dijkstra's algorithm. In that, while applying Dijkstra's algorithm, if I take source as S, can you say what are the sequence of vertices which you identified? Can you go ahead, apply Dijkstra's? Can you apply Dijkstra's algorithm on this? But remember, strictly shortest path, strictly shortest one is available, then only update. Otherwise, don't update. Strictly shortest one is coming, then only update. Otherwise, don't update. Yeah, can you apply Dijkstra's algorithm one time? Can you show options? Someone is saying, can you show options? Some options are there. Yeah, I will try anyhow. I will try. You people are tried. I will try now. Let me try. Let me try once. So indirectly, directly, Dijkstra's algorithm. If anyone don't know Dijkstra's algorithm, if you don't know Dijkstra's algorithm, after this class over, if you don't know Dijkstra's algorithm, after this class over, you don't know Dijkstra's algorithm. After this class over, you can check one time. So let me start once. So I am using some color. I think black color I am using. I am using black color. Everyone listen. So starting from starting vertex, starting from S. So initially everywhere, minimum distance is infinite, parent is null. Just keep everywhere infinite null. Just keep everywhere infinite null. If anyone don't know Dijkstra's algorithm, I request you all, after class over, please visit the Dijkstra's algorithm. After class over, please visit the Dijkstra's algorithm. Start from starting vertex. So starting person is because of starting to starting 0 and null. That is okay. So everyone is infinite null. Now see the answer. Start from starting, adjacent people all update. Starting from SO, adjacent people all update. What is the answer? SC is already 0. 0 plus 4 is 4. Comparing infinite, 4 better. From where? From where? Right? Can you help me now? From where here? From which place you came? From which place you came? Right? So listen everyone now. Listen everyone now. So A is thinking that no path available from source. A is thinking that no path available from source. So right now SC is informing that I am the source. There is a 4 rupees path is available. From which place? From S, there is a 4 rupees path is available. So update all the people like this. Update all. So SC is informing to D, no path available. No path. He will say 7 rupees. 0 plus 7, 7. From where? From S. Like that. Right? Next one. S will inform to B also. Right? You are thinking no path available. So 0 plus 3. 0 plus 3. 3 rupees path available. From where? From S. Like that, everyone, all adjacent people will inform. All adjacent only. Yes will inform to all adjacent people. You people are thinking no path available. There is a path available. From where? Who informed? Yes. So like that. Now yes is informed to all neighbors. Perfect. Yes is informed to all neighbor. It's perfect. Now yes is completed. S is completed. Now in the available people, who is the minimum? Find out. Remember, first already S is already done. Yes, already done. According to Dijkstra's, I have to start from starting state. I started. Now in the available one, best one. One person is 3, one person is 4, one person is 7, one person is infinite. Remaining all are infinite. Best one is, I think, after S, next B. Next B. Remember, already completed people, no need to change because they are already minimum. See, yes, already 0. Yes, already 0. No point of going back. Yes, already 0. No point of going back. New people only try. Now listen, I am at B now. So B adjacent which are not done. Right? See, is all cancel means completed. B adjacent people which are not done, which are not completed. I think B adjacent is only D. So B already 3. 3 plus 4 is 7. But already 7. In the problem, if you see, strictly less than only change. Same don't change. Already B is 3. 3 plus 4 is 7 to go to D. Already 7 there. Don't update. Only one person adjacent. Actually, B adjacent is yes also. But completed people, you no need to go. So B adjacent D only. Total 7. Already 7 there. You no need to update. So B successfully over. This is the change. Now listen, after completion of this, now existing people, who is the better one? I think A, because A 4, same story. Right? After B, next one is A. Go to the A now. A adjacent people, find out which are not completed. A adjacent is 1 C. 4 plus is, I think this is 1. This is 1. 4 plus 1 is 5. Comparing infinite, 5 better. From where? A. A adjacent is only 1. So change it. So I think A also completed. Now in the available people, 7 is also there, 5 also there. So 5 is better. So after A, next C. Now adjacent people all inform. Adjacent people, all the people inform. Adjacent people, all the people inform. So what is the answer? Is the infinite none. So what is the answer? Let's check. C adjacent is going to be G also, E also, D also. Let's check. 5 plus 3 is 8, but 7, don't update. 5 plus 1 is 6. From where? C. Next one. 5 plus 2 is 7. From where? C. So all the things are done. So C also completed. Next one, in the available people, if you observe, 7 there, 6 there, 7 there. I think 6 better. Go to the E. Go to the E. If anyone don't know Dijkstra's algorithm, you cannot get this. If you don't know Dijkstra's algorithm, you cannot get this. Go to the E now. I am at E now. I am at E. E already 6. E adjacent people, if you see, I think E adjacent is only 1. I think T. E adjacent is only 1, that is T. So 6 plus 4 is 10. From where? E. E also done. Check if I done anything wrong. Only one person. Okay, fine. Now in the available people, if you observe, 1 is 7, 1 is 10, 1 is infinite, 1 is 7. So I think 2 7s are there. Whatever 7 you want, you can take. So now observe clearly. Until now answer is SBACE. See the answer. SBACE. Listen, SBACE. Anyone? Anyone check what is asking? Starting from what X says, what will be the sequence of what he says identified by the Dijkstra's algorithm? What is the answer? Let me write now. E option. First to S, next to B, next to A, next to C, next to E. Okay? Until now, this is the current status. Until now, this is the current status. Now, in the available people, better one. See, 2 7s are there. Whichever 7 you want, you can take. G also you can take. D also you can take. G also, D also. Let's go to G first. Let's go to G first because both are 7 only. Both are 7. Let's go to G first. I think G already 7. 7 plus 3, 10. Already 10 there. No change. You cannot go back because they are already done. Right? Next one. After G, next one, I think 10 and 7, I think you will go to the D. After 7, after G, you will go to D. Let's go to D. Let's go to D. This also completed. This also completed. Let's go to D, 7, right? D adjacent people, all you check. 7 plus 3, 10 already there. 7 plus 5 is 12. From where? D. Right? Afterwards, I think in my opinion, after D, next one is T. Next one is T. Now let's go to T. Let's go to T. D over. Next, let's go to T. Now T is 10. 10 plus 5 is 15. I think 12 better. 12 better. After T, next one is F. Same way here also. Same way here also. After D, next one may be G. Right? Next one T, next one F. Something like that. Something like this. Right? Both are Dijkstra's algorithm. I am not done anything new here. I am not done anything new here. Simply Dijkstra's algorithm. Dijkstra's algorithm, please apply. Dijkstra's algorithm, please apply. It's the answer. See, no option matching. It's okay because it belongs to some other problem. It belongs to some other problem. I changed it a little bit. Assume that in any iteration, the shortest path to a vertex is updated only when a strictly shortest path to B is discovered. Starting from vertex X, what will be the sequence of vertices identified by Dijkstra's algorithm? It is some other problem. I changed it. Options I didn't change it. I changed the content. Options I didn't change it. I changed the content. Answer is either E also, F also. Please go through Dijkstra's algorithm. There is no need to discourage also. Apply Dijkstra's algorithm because Dijkstra's algorithm I used to cover Dijkstra's algorithm I used to cover in 5 hours. 2 classes required. Dijkstra's algorithm, two classes required. I cannot say everything here. I cannot say everything here. Dijkstra's algorithm, I cannot say everything here. It is impossible. It is impossible to say in 10 minutes Dijkstra's algorithm. Just roughly I done. Roughly I done. Remember, same thing, you need to change it. That is the only condition here. If same thing coming again, 2 10s are there. Already 10 there, one more 10. You no need to update. Old 10 only continue. Old 10 only continue. New 10 don't take. New 10 don't take. Right? Now, I think same problem, you can try this. There are multiple shortest path between OTCS SNT. Which one of the following will be reported by Dijkstra's shortest path algorithm? Assume that in any iteration, the shortest path to a vertex V is updated only when a strictly shortest path to V is discovered. See, multiple shortest path between OTCS SNT. Which one of the will be reported by Dijkstra's algorithm? Assume that in any iteration, shortest path to a vertex V is updated only, right, discovered. S2T, you want shortest path. Finally, S2T path required. Can you go there? Can you go there? Can you go there? S2T, S2T. What is the shortest path? Strictly shortest path means if less will come, then only do, then only change. Same coming, don't do. Strictly means strictly less coming, then only update. See, already 7 there. One more 7 coming, don't update. Already 7 there. One more 7 coming, don't update. Strictly less than 7 coming, then update. So finally, if you observe clearly, right, S2T, what will be the path? Everyone know. What is the answer? T parent is E. See, parent is there. T parent is E. Where is the E here? T parent is E parent is C. What is the C parent? C parent is A. What is the A parent? A parent is S. This is the path. This is the path. What is the answer? I think S to A. S to A to C, C to E. S to A to C, C to E, E to T, and so on, and so on. So if you observe clearly, what is asking? In any iteration, the shortest path to a vertex V is updated only, right? I think this is the problem, right? This is the problem. See the option. S to A to C, E to T. This is the answer. D option. Simply Dijkstra's. I am not done anything. Please go through Dijkstra's from the class notes one time. Please go to Dijkstra's from class. Someone is saying S to D, D to T also possible. Let's check. Let's check. S to D, okay. S to D, okay. Next one. D to C. So there is no way to go from D to C, right? S to D, D to E, E to T. So, but remember, I cannot go whatever way I like. See, IN, I cannot go whatever way I want. See, there is a parent. At the T, parent is E. See, go to E only. E parent is C, go to C only. C parent is A, go to A only. A parent is S, go to S only. S parent is null, means you reached the source. You reached the source. D to T. That's what I am saying. That's what I see. Multiple paths are available. Whatever path is coming, that path only how to select. You cannot. So why are you going? So why are you going? S to D. Why are you going? See, this one you have to follow. This one you have to follow. See, start from the destination. Start from the destination. Allow T, you came from where? E. Go to E. Allow E, from where you came? C. Allow C, from where you came? So, right, allow E, from where you came? C. Allow C, from where you came? A. Allow A, from where you came? Yes. Allow S, from where you came? Null. So like that. So like that. So answer is S to A to C, C to E, E to T. Right? This is the answer. Fine. Now, so those people who are saying SDT, those people who are saying SDT, let's go and check. SDT. SODT. How much it is? 7 plus 3, how much? 7 plus 3, how much? 10. Now, you go the mention in the problem. Are you identified? See this. Are you identified? That is a trap. See, that is the trap. That is the trap here. See this one. There are multiple shortest path between vertices S and T. There are multiple paths. But remember, which one will be reported by Dijkstra's shortest path algorithm? Assume that this is the important one. If this condition not there, option A also correct. This condition not there. Option A also correct. This condition there. What is the condition saying? Same person again coming. Don't update. This is the condition. Because of this condition, only D is the answer. Only D is the answer. If this condition not there, A also, maybe D also, maybe some more. He said many things. See, multiple shortest path between vertices S and T possible. He already said possible. But this is the condition. To get the one answer, this is the condition. To get the one answer, this is the condition. To get the one answer, this is the condition. Try to understand. To get the condition, this is the answer. This is the answer. To get the condition, this is the answer. If this is not there, A also correct. D also correct. This is the, see, he knows very well. Many people, he knows very well. Many people will tempt, they will give answer as A. He knows very well. See, I didn't get blindly this path. While applying Dijkstra, see, every time I am taking minimum. Same person coming again. I'm not updating. See, already 7 someone else is giving. I'm not updating. Already D cost 7. Someone else also given 7. I cannot take. Whatever first 7, I have to take it. If 2 paths are giving 7, first 7 only I have to take. So see, 2 people are giving 10, but first path only I will take, whichever you came first time. So that twist in this problem. So those people who are not getting, please try Dijkstra's algorithm one time. My request to all the people, Dijkstra's algorithm one time you try. Dijkstra's algorithm you try one time. Dijkstra's algorithm you try one time. And one more thing is, if anyone is not taken EPT RIC course, you can happily take 5,000 questions we are going to discuss. 5,000 difficult questions we are going to discuss. These are our this year topper and previous year topper. These are our this year topper and previous year toppers. This year topper and previous year toppers. And one more thing is EPT celebrating its 5th anniversary, 80% discount going on. You can utilize it. It is celebrating 5th year's anniversary. 5th anniversary. 80% discount going on. You can use it. This is the code. You can use it. EPT 595 ARG. EPT 595 ARG. Right? So many courses are there. You can go for combo offer. Regular course you can go. Regular course for CSE. 1 year course here. Right? 1 year course for DA you can go. Right? Regular course for the CSE, DA you can go. Both GATE CSE, GATE DA. 1 year course. Foundation course. 2 year course. Right? Next one. RIC course also. Only practice course there. Go to website, you will find out. Next one, if you are preparing for a DSA, right? So placement purpose, DSA you can go, right? Placement with the right? DSA with the system design you can go. Web development, app development, there are many development courses are there. You can utilize it. Right? You can utilize it. So wonderful opportunity going on. Please utilize it. So I think we done some good problems today. Yeah. Can you try this also? Everyone try this problem. Can you try this problem? Someone is saying, I is saying that, sir, I enrolled few days back. Can I get the PDFs? Iron, you will see all the videos you can see one time. Lastly, if you want PDF, I will give. Right? All the things one time you see. All the classes you see one time. And you no need to go to total video also. See the problem. If you think problem is a little difficult, then only see the video solution. If not, it is not difficult to you. Please go to next problem. Please go to next problem. Difficult problem, then only see the video solution. If not difficult problem, if you feel, you can skip to the next problem. Do like this. After everything is over one time, you ask me, we will give the PDF. Fine? Yeah, can you go ahead? That's what I'm asking. After completion, I will give. Surely. Can you go to this problem? Can you go to this problem? Consider the process of inserting an element into a max heap, where the max heap is represented by an array. Suppose we perform a binary search on the path from a new leaf to the root to find the position of the newly inserted element. The number of comparisons performed is. It's a very nice question. It's a very nice question. Can you do this? Can you do this? Everyone try this. It is a max heap insertion. This is max heap insertion. This is max heap insertion. Can you try this? Can you solve this problem? It's a very tough problem. Let's see how many people will give. Try this. Try this one. It is a max heap. It is a max heap. It is a max heap. In the max heap tree, series one, he is talking about some deletion or insertion. Consider the process of inserting an element. See, in the max heap tree, if you want to insert the new person, right, you will insert in the first gap, I think here. So until here, elements are already there. Because of it is already max heap for n people, already log n levels are there. Already log n levels. You may say that, sir, how log n levels? Can you see? Consider the process of inserting an element into max heap, where max heap is represented by an array. Suppose we perform a binary search on the path from the new leaf to the root to find the position of the newly inserted. The number of comparisons performed is, right? I think could have number of elements you could have given. So inserting an element into max heap of n elements. Right? You could have given this line. Otherwise, what is the n? Consider the process of inserting an element into a max heap of n elements. When you say n elements are there in the max heap, log n levels are there. N elements max heap, log n levels are there. N elements max heap, log n levels are there. Please careful. N elements max heap, log n levels are there. Please be careful. Now I am inserting. Can you insert here? Everyone observe here. Can you insert here? You have to insert one new element here. Now, normally what happened is, if you observe, when you insert the element, you have to ask the parent. Problem there, spam. You have to ask the parent. Problem there, spam. You have to ask the parent. Problem there, spam. You have to ask the parent. Problem there, spam. So, for one insertion, if you observe clearly, you will insert at the bottom, right? So you have to compare in that path every person. So log n comparisons, log n swaps. Everyone you are comparing, everyone you are swapping, 2 log n. Finally, which is nothing but order of log n. Right? One insertion will take every person swap in that path. Log n comparison, log n swap, 2 log n, which is nothing but a big O of log n. So this is the actual story. But what he's saying is, in this path, instead of asking every person, why don't you do binary search? That is the question what he's asking. Instead of asking every person in this path, why don't you do binary search? What is the meaning of binary search? Right? This person don't ask everyone. This person will ask this person, middle person. Middle person he will ask. If the middle person will say no problem, if the middle person will say no problem, so right, middle person saying no problem, then I will come down and I will ask. If the middle person also saying problem, I will go upper. So instead of asking everyone, ask the middle person. If the middle person say no problem, come below and ask. Middle person say problem there, go upper and ask. Again upper out, again middle. So again middle, I will do. Simply binary search. Suppose after finding correct person, assume is the correct person. Assume this person is the correct person. Then what you have to do is comparisons already in this log n people you are doing binary search. Number of comparisons became log n comparisons. Because n people linear search will take n time. Log n people linear search will take log n time. But n people binary search will take log n. Log n people binary search will take log n comparison. After doing log n comparisons, I got to know this element should goes to here. Okay, log n comparison over. But whenever this element will go here, where this element will go, it will goes to here. Where this will go to here. Remember, swap operations are still log n. Swap operations, you have to swap with everyone below. So log n comparison, log n swap, overall log n plus log n becomes log n. So time complexity is still log n only. If you do linear search also log n, if you do binary search also log n, answer is still log n. Answer is still log n. Comparisons are, is he asking comparison? If comparisons are asking, only comparisons are asking, then answer is log n. Time complexity asking log n, but in the problem is asking only comparisons. Only comparison, then go to B. Time complexity, answer is log n. Now, those people who are still facing the problem, I am giving some idea. See this one, max heap or min heap. I am just giving idea, please check one time. Max heap or min heap? Min heap. Insertion time. Normally we are doing linear search, which will goes to log n comparison, log n swap. Right? Max heap, min heap, insertion time, we are using linear search. Log n comparison, log n swap. So finally log n. If you use binary search, log n comparisons, log n swap, overall log n. If anyone don't know how, please can you check? Please can you check? If anyone don't know how, please check. It's one of the nice problem. Comparisons are log n. Swaps are log n because you have to swap with everyone. You cannot swap random places, right? You have to swap everyone in that path. Everyone means in this path log n people are there, log n. But you are doing binary search for a comparison, log n. Log n comparison, log n swaps, overall became log n is the bigger one. Time complexity log n, comparisons are log n. Right? Fine. Thank you, Manasi. Thank you so much. Thank you. Yeah. Anyone having any issue, let me know. Anyone having any issue, please let me know. Check once. Try everyone. Anyone having little doubt also? Little doubt also. If anyone having, please use this offer. Please use this offer. If anyone is not taken, please use this offer. Use this. Little doubt also there. Little doubt also there. You can ping me. Sir, this problem I am still not fine. Reddy sir, I am still not fine. You can WhatsApp me. I will help you. Sir, this problem still I am not happy. I didn't get. You try. If you still didn't get, you can WhatsApp me. I will help you. Sir, this problem still not okay to me. You can use this code. You will get the discount. Yeah. Chalo. We'll meet in the next class. Right? Fine. Yeah. Thank you, Manasi. Thank you, Ayan. Thank you, Sakshi. Thanks, everyone. Good night, everyone.